Friends, we're continuing to model our aerated concrete house. Today is our 8th lesson. In the last lesson, we added the floor slab and ceiling. In this lesson, I wanted to get started with the building process. But let's touch on another important topic that many people overlook, but some of its points are very useful. Specifically, let's talk about the view cube. The view cube is located in the 3D view and can be enabled or disabled. The view cube settings file is located in the view cube section. We enabled it in configured all the necessary settings at the beginning of our course. All the settings are intuitive, so we won't dwell on them. We'll move on from here. The view cube is enabled. It's a useful tool for navigating the 3D view. It also has a context menu. Let's talk about this context menu and the functions it contains. You can open the context menu with this button. The first option is to press it, or simply right-click on the 3D view on the view cube. Right-click. The first item in this menu is Sunrise View. The program returns your 3D view to the original, so-called original view. What is the original view? You can rotate and twirl the model in any view you like, and save it as the original view. Let's say you need this view and need to save it as the original view. Right-click on the view cube. Name the current view as the original view. And then, if you change this view, you can always return to it. Click to return to the original view. The last view you set as the original view will be applied to this 3D view. The next point, save the view. You can save this original view separately. That is, click Save. Give it a name, and it appears here. Another view appears in the 3D view. Here it is. The only thing is that all the graphics settings of the main 3D view disappear. So they are transferred to this view. So remember, let's delete this 3D view that we created. But before deleting it, let's immediately show some useful ones. Save a template from the 3D view template. 1. Let's call it anything. You like. Click OK. Choose a category where to store this template. Let's say it's all categories. Click OK. Let's delete it. We don't need it. The main one is in brackets. It can't be renamed or deleted. Let's return the graphics we had. Here's a quick way to do this. We saved the 3D view template from the view we just deleted. Right-click here, Apply View Properties. Select the template that saved. Click OK. All our graphics are restored. All our graphics settings are restored. The only thing is the axes. He left the axes, so they are visible in the 3D view. In the Properties panel, there's a section called Show Grids. Here, you need to mark the level at which you need the axes. Right now, floor 1 is marked. You can also mark floor 2, for example. The axes will appear on the second floor. Either remove these axes altogether, show the grids, change them, uncheck all these boxes. That's the first option. The second option is you can leave one floor here, show the axes. But you can simply turn off the display of these axes in the Override Graphics Visibility. In the Annotations category, uncheck the Axes box, click OK. The axes will disappear. Let's undo the actions, but what about showing them? Let's just uncheck the grid from floor 1. We don't need the mosey for now. That's all in the template that you applied. It will always be here in the identification section of the properties panel. Now we don't have any template applied. You can apply one template again, let's say. It will be applied while the template is applied. You can't change anything about the graphics by overriding the visibility of the graphics. Everything is closed because the template is applied so that you can change just the view template. Turn it off, set it to no, that's it, remember this moment. Let's move on, according to our context menu. The right button is Save View. It's clear what it is. Perspective switches our 3D view. As if creating some kind of observer, and we see our model with some perspective. From some distance, and not very convenient for work. When designing a project, it can be useful, but as a rule, the perspective can also be done differently and in the 3D view, perspective is usually not needed. Let's return to the mode orthogonal. The right button is orthogonal. That is, the mode in which all our faces are perpendicular, parallel to our axes. The next menu item, Set Front View, assigns the view. That will be reflected on the view cube as the front, that is, the front view. You can set any facade, for example, north. Here, you have a facade. That is north, it will become the front view. You can change the front view. For example, set it to west, the western facade will become the front view. Click here, and the facade you set. Switches. Then, Restore Front View undoes this action, resets the front view to the default, and assigns the south facade. Then, Show Compass. That's clear, the view cube has a compass, which you can either show or hide. By the way, the compass can also be used for orientation. Let's return to the original view. Next, orientation by view. What is that? Well, the name speaks for itself. You can navigate by view, by specific plans, elevations and sections. Let's say we have floor plans. Floor 1, Floor 2, and the top of the Harmopoulos plan. Let's click on the floor plan for Floor 1. What's happening? The program automatically activated the 3D view boundaries and cropped the 3D view to match our current cutoff range on the first floor plan. We can't see the floor in the bathrooms, for example. Why? Let's take a look. Open the first floor plan, go to the cut range. We have the bottom of the cut range is floor 1. We have no offset. That is, we don't look down from the level of floor 1 at all. If we set, say, -300. Let's say here and change the projection boundary to -300 as well. We already discussed the cut range in the previous lessons. Click Save, OK, and return. To 3D View 5, right-click on the view cube. Orientation by view, floor plan. Floor plans, select floor 1. You can see what happens. It cropped the model in the same way as our cut range is set up. That is, you can clearly see in the isometric view in 3D how your cut range is set up in the view. You have a facade. You've set the current range so that you look down 30 centimeters from this level and the 3D view. Like that. Has been cropped. I hope so. I mean, I wouldn't say it's a super useful feature. But I use it to understand the clipping range. To understand how the clipping range is set up on a particular plan. Let's return to the original view. We'll uncheck the view boundary. We won't crop anything. Next, orientation by view. The next item is elevations. Well, everything is clear here. You can quickly orient yourself from a specific elevation. Everything is clear here, no explanation required. Next, sections by view. Here's an interesting point. Look, we have one section. Let's go to the floor plan. We created an auxiliary section for our constructions. Here is our auxiliary section. It is displayed in the Project Manager in the Sections tab. And what is orientation by this section? Let's return to the 3D view, boundary. Let's remove it. Right-click on the view cube again. View orientation, sections, auxiliary. It simply crops the 3D view with the same frame so that your section is located, you can switch to the section. That is, your section is directly in the section. It crops the 3D view, oriented the 3D view along this section. That is, this function is also in the program. And note that it well, the section has some kind of cutting plane, of course, but besides this, there are also sections. Let's go back to the first floor plan, select the section, it also has this depth. So we can adjust it depending on this depth. Orient by plane. You can select the plane along which we need to orient our axis. For example, we already touched on the topic of working planes in the course on frame house design. It is relevant there for designing a frame, for example, in a slatted board. I'll explain it briefly. Architecture. Set. Select a plane, let's say a working plane. You can select a working plane, like the face of this wall. This means that this plane of this wall, the face of this wall, will now be the working plane for the program, meaning construction will be performed on it. If you orient yourself to this plane in the 3D view, here it shows, we now have a plane. See, it's currently highlighting the one we selected. Click OK, and it will orientate to this plane. Let's go again. You can select, say, this architectural plane. Set the plane. Select this plane. Orient to the plane, or choose the working plane. We assigned, or we can specify the plane ourselves. Either select a segment, use the working plane it's located on, and click OK. It orients us along this plane, but not along the section. It's specifically on this side, where the plane is, so we can see it. Not like this, not from above, because we won't see it. We need to have this plane there, so we can look at it. In other words, that's the kind of lesson we had that was a bit off topic. But I think this topic needed to be covered. We talked about the view cube. If you have any questions, please ask. In the next lesson, we'll start modeling our roof and discuss in detail the dependencies, the basic dependencies for the walls and for the roof slabs. In this project, we have a gable roof. It's standard, but we'll also look at how to do it. Cut one roof into another, how to make a dormer window, and talk about these tools in the program. If you liked the lesson, please don't forget to give it a like. Close all inactive windows. Save our project. And move on to the next lesson.